In this session of looking at GeoGebra, we're going to take a look at basic algebraic input. Although a lot of the work that GeoGebra is designed for uses the drawing pad itself and the axes, one of the most useful tools is to just use GeoGebra as a very sophisticated graphing tool. To do so, we'll use the input bar at the bottom of the screen. We can type in an equation, usually in several ways, but let's start out by one that's usually familiar to everyone, and that is standard y equals mx plus b form. Y equals 2x plus 5, just typing from the keyboard. When we hit enter or return, we find that line is graphed for us, and at the same time the equation shows up on the algebra side of our window. It's labeled as A, and we see the little label right over here beside the line, and the equation y equals 2x plus 5. Let's put in another one just for comparisons. Y equals x minus 4. Again, hitting return, there's the line y equals x minus 4. It receives a different label, but its equation shows up. It's now identified as graph B, y equals x minus 4. We can change any equation that we have a couple different ways. One of the simplest is we'll go to the equation A, double click on it, and we get the same type of thing that we would have in word processing or in a spreadsheet. We can go into the equation and change the number that we had in there to a 3. We had 2x plus 5. I've changed it to 3x plus 5, and as soon as we hit return, it changes it now to a new slope. Still have the same intercept. So very simple. Just go in, double click on an equation, adjust whichever number you want to use, hit return, and you've got a new equation on display. If we wanted to change the equation entirely, we could redefine it. For example, if I go to the entry bar, I could type in A to tell the computer that A is being changed, and I will type in a new definition for, let's say, y equals will help. Y equals negative 3x plus 1, hit return, and now what we've done is we have actually redefined the entire equation by designating as A and then giving A new definition. If we do not put in the letter, for example, if I just put in y equals 4x minus 7, it won't change either of the two existing equations. When I hit enter, it simply creates another equation labeled C. Once we've created equations, it's very simple to work with them. If we choose the selector tool or the move tool, we can come to an equation, for example, here's line A, and we can move it. When we do, we notice that not only does the line move, but the equation adjusts itself, as you can see over in the algebra window. As I move line A from left to right, the intercept point is changing. I can always go back to its original location by using the undo command, and there I am back to the intercept of 1. You're not limited in using the y equals mx plus b form for an equation. For example, we could enter a different equation for a line. We'll go back to our input bar at the bottom, but instead of having to start with the letter y, we could just type an equation of the form x plus 3y equals 7. Let's try that again. X plus 3y equals 7. That's better. And hit enter, and there's our equation. Notice that it's displayed in the way we typed it. X plus 3y equals 7. That's now an equation being graphed for us. Very few computer programs can handle that type of graphing. Usually you're forced to solve first for y. GeoGebra does that work for you. We can also put an equation in the form of a function. For example, back in the input bar at the bottom, f of x equals negative 4x plus 1. Now let's see where that ends up. Okay, that line or function f is now very close to line A. If we change it, let's modify it slightly. Let's give it a different intercept, perhaps negative 2. Again, I'm clicking on my function. I'm going to go into that and remove 1, insert negative 2 here. Even if I don't take out the plus sign, we end up with an equation or a function that now does pass through negative 2. It's also possible to put equations in parametric form. That's a little bit more complicated, but the possibility is there, and we'll take a look at that in some of the later lessons. GeoGebra will even allow us to name a line. For example, suppose we wanted to name our line Sally. We would simply go to our input bar, type in Sally. This does have to be a single word. If you want to use 2 words, they have to be put together or use an underscore symbol. You cannot use spaces. We put in a colon, and let's suppose we want Sally to be the equation y equals x. It could be anything. Press return, and now there's our line y equals x. We've simply called it Sally. If you have a whole series of equations you want to compare, then being able to name them like this can be a very useful thing to have. You can always adjust a bit. For example, Sally is touching the line, so we'll just grab Sally and pull Sally to one side so that the label doesn't interfere with the line itself. Let's clear our window. Actually, let's get a whole new window before we continue, since that one's getting rather cluttered. We've looked at just some linear equations so far, but the equations could just as easily be much higher level. For example, how about a parabola? Y equals x. We use the shift 6, the caret symbol. Now, notice that in the input bar right now, it's showing up with the caret there. As soon as we hit return, we get our parabola, but now over in the algebra window, we notice that the equation is spelled out correctly, y equals x squared in the normal notation. You don't have to stop and explain why the notation doesn't look like it does back in the textbook. As with the linear equation, if we click on that parabola and move it, the equation automatically changes itself. Again, this is a feature that did exist only in some very expensive programs until fairly recently with programs such as GeoGebra. We can always return to our default by using the undo button. So now we have a parabola in place. Again, we can do some things that are next to impossible on a lot of programs and in calculators. Let's type in the parabola x equals y squared. Now that we know is not a function, which is why it does not work in most other instances, but here it is. There's our sideways parabola. It is a relation, not a function, but GeoGebra is able to graph it correctly. Let's go a step higher. Let's suppose we put in a fairly high-level polynomial equation, such as y equals x raised to the 5th power minus 2x raised to the 3rd power plus 1. And this could also be put in the form of a function, which would actually open up some other possibilities for some more advanced uses of the GeoGebra tools. Let's see what this looks like. There we have a polynomial equation, and it is a 5th degree polynomial, and it behaves as it should. This is an example where you could very easily go into the equation, change that to a negative, and watch the result. Now we have a quite different equation by changing just the leading coefficient sign. Opportunities to explore virtually every aspect of polynomial equations. We won't take time to look at it here, but you can do everything from draw tangent lines to find inflection points, find roots, even do some calculus functions such as derivatives. We're not limited just to polynomial functions. Let's take a look at a trig function. We'll put in y equals sine of x, and there's our sine curve. We could do just as nicely with the cosine curve, the tangents, and pretty much anything we want. Finally, let's take a look at a fairly simple one. How about absolute value? Now, this one actually has a shortcut, as does sine. In the window or the menu bar just to the right of the input bar, we have what will normally look, let me go to the original one, normally all you see is the degree symbol, but it actually is a menu of several functions. If we scroll down through, we see quite a few functions and operations available there. The one we want would be absolute value, and here it is, ABS, similar to what it is in many other graphing programs. So now we have the absolute value of x, and I need to take out that degree symbol, which appeared accidentally. Hit enter, and there's our absolute value function. There you have a look at some of the basics of algebraic input into the GeoGebra program.